Last time we were talking about calculating doses for a given sort of problem where you have a patient and you have some information about the patient, you have some medicine, and you need to calculate how much of the medicine should you give the patient. And we talked about how you can do that and make sure you're doing the right thing by keeping track of all of the units involved, which is also called, the fancy name for this is dimensional analysis. But it's really just keeping track of units. That's what you're doing. We kind of looked at the easier cases there where you're just figuring out how much medicine to give. Sometimes, though, you have to be a little more involved, because sometimes what will happen is you don't just have a formula that says, okay, here's the amount of medicine to give based upon some measurement of the animal. You may actually have something where you figure out the dosage that you need to give of the medicine, but then you need to figure out how much of the solution to give the animal. So here's an example where this kind of thing is important. And this actually kind of comes from a real life example involving my animals. As you know, I have rabbits. One of my rabbits is on various pain medications because unfortunately he's old, he's got some arthritis problems, and the vets actually mix up one of the medicines that they gave him themselves. Well, what they have to do is they need to work out first, when they've mixed up this medicine, what's the concentration of the medicine in this solution, and then how much of this solution should they give. So they basically took some pills and they ground them up and they mixed them into some kind of liquid. I don't know what exactly the liquid is, but they mixed it in there so that we can give it to him orally using a syringe. So what I need to know ultimately is how many cc's should I give him? But the dose is actually going to be in milligrams of these pills or of this powder that we want him to get. So let's take a look at that kind of example, and we'll see how it's actually the same sorts of things that we've been doing. It's really just an extra step of the same kind of stuff, okay? So nothing too terribly, like, subtly, amazingly new, but it is a new thing that we've got to be careful about. So let's suppose that an animal should get 4 milligrams of medicine per kilogram body weight. And there are 7 milligrams per cc of solution. How many cc's do we give an 8 kilogram animal? Okay, I don't know what kind of animal this is or what kind of medicine. I mean, those are all the kinds of things that you will learn in your actual vet courses, okay? I don't want to, like, make up some numbers for any real medicine, so we're just going to pretend this is some kind of medicine, some kind of animal. These are the numbers. But what you do in those real situations, it will be the same as what you're doing here. You'll just, instead of some animal, it'll be like, oh, here's a small dog. And instead of just some medicine, you'll have some specific medicine. So the first thing we want to do is we want to take the measurement of the animal, in this case the body weight in kilograms, and convert that into a grams of medicine that we want to give the animal. So we're going to start with the 8 kilograms of body weight, and we multiply that by 4 milligrams of medicine per 1 kilogram of weight. Now, you'll notice here that instead of just writing the units, I wrote weight and medicine in sort of abbreviated form here. Hopefully that's kind of visible on the camera. I don't have a lot of room on this board, unfortunately. The reason why I'm doing that is because I don't want you to confuse the two different weights. This is a body weight of an animal measurement, This is a milligrams of medicine measurement, and they're kind of two different things, even though they're both measured in grams. That's why I can't just cancel this grams somehow with these kilograms or anything. That wouldn't make sense. You can't cancel weight of medicine with body weight of patient. But what we can do is we can cancel out these weight units together. And this gives me the milligrams of medicine that we have. Now, I need to multiply this in order to get this transformed from milligrams of medicine into cc's of solution. And here's the thing. If there's 7 milligrams per cc, then that's 7 milligrams per 1 cc. That means that there is 1 cc per 7 milligrams. In other words, these are kind of like conversion ratios. And in fact, this is milligrams of medicine. So if I want to cancel out units of milligrams of medicine and end with cc's, I can multiply by this 1 cc per 7 milligrams of medicine, and I get 1 cc over 7 milligrams of medicine. Milligrams of medicine now cancels. This is in cc's just like I wanted. So this is going to come out to be in the correct units. And that is why keeping track of your units, and not just your units, but what they represent, is important. That's where this dimensional analysis stuff is going to come into play to really help you. It makes sure that you are really doing what you are supposed to do when you're supposed to do it. You're using the correct ratios here, because if you use the wrong ratios, the units won't work out. If you use the correct ratios, then they should work out. Now, I suppose in theory, it's possible for you to write down an incorrect equation where the units still somehow manage to work out. Maybe you made a bunch of mistakes, but the units still all cancel in the right way and you get the wrong number. But keeping track of the units is a good way to make sure that you're doing the correct thing. It's a good way to check yourself on this. So to finish out this problem, this comes out to be 8 times 4 divided by 7 in cc's. Now, 8 times 4 is 32, so this becomes 32 over 7 cc's, and that is equal to 4 and 4/7 cc's. Now, normally, you probably won't be able to necessarily measure 1/7 of a cc. So you should consult the manual and say, okay, should we just round this to like 4.5 cc's? How accurate exactly do we need to be? That's something that you would want to consult the documentation that comes with the medicine, or if you're doing this on the orders of a vet, then you could ask the vet. But some of you are going to be vets yourselves, so you guys will have to just learn how to round these things to a measurable unit in your vet classes. But that's the idea here. So let's take a look at another example of doing this kind of thing. Let's say that horses get 6 milligrams of medicine per inch of height at the withers. And each tablet has, I don't know, let's say that each tablet has 20 milligrams of medicine. And we want to know how many tablets do we give a, let's say, 65-inch horse. Okay, sorry, long problem. These problems are kind of lengthy to write down, but so let's see how you can go ahead and do this problem. Same idea as last time. It's just that this time we're going to be working with tablets and with inches of height. instead of working with the various body weight and cc's, okay? But it's the same kind of idea. I need to end with units of tablets. Now, you might think it doesn't make a lot of sense. Tablet isn't a unit. Well, yeah, it kind of is. It's not a standard unit, but it's definitely a kind of a unit. How do you know if something's a unit? Well, the question is, can you physically tell what something is in terms of that unit? Like an inch is a very specific length. I can measure a length by just lining up a bunch of inches. A tablet is a specific physical object. I can count the number of tablets I have. So yeah, tablets are actually a unit. Of course, they're not a standardized unit, but for our purposes, they basically act like a unit. Okay, that was a long way of saying treat tablets like units in this problem. So we want to start with our inches of horse height, or height at the withers. And we want to end with units of tablets. Now, the first thing I need to do is to convert, not really convert, but calculate, which acts like a conversion from the height of the horse to the needed milligrams of medicine. So I take the inches and I multiply that by 6 milligrams of the medicine per 1 inch of height. And the inches are going to cancel here. I'm not bothering to write down inches of height because there's only one unit of length in this problem. So I don't need to worry about accidentally canceling out two things that are both measured in weight, but they refer to two different types of weights. In the last problem, I had to differentiate between the weight of the patient versus the weight of the medicine. I don't want to cancel those things together. But in this case, there's no danger, so I can avoid having to write, oh yeah, this is inches of the patient's height. So this is going to give me the amount of medicine I want to ultimately give this horse. Okay, now the problem is I can't just give the horse a certain number of milligrams. I have to compute a number of tablets that this horse is going to get. How do I do that? Well, there's 20 milligrams per 1 tablet. I'm just going to abbreviate tablet as tab. So this acts like a conversion ratio. That means there is 1 tablet per 20 milligrams of the medicine. So I can multiply this by 1 tablet divided by 20 milligrams of medicine. The milligrams of medicine cancel out, and I'm going to be left with something that is in tablets. So we get 65 times 6 divided by 20 tablets. And what is that going to be? So this is 650, 325 plus 65 is 390. Over 20. And that is going to come out to be 39 over 2. Sorry, I need to keep track of the fact that this is still tablets. So this is 39 over 2, which is going to be equal to 19.5 tablets. Okay, that's a lot of tablets, but it is a horse, so, you know, we probably do have to give it quite a few tablets. And maybe if they're horse tablets, maybe somebody made bigger tablets for horses or something, but I made up these numbers for the sake of the example. One thing to notice, by the way, when you're thinking about cutting up tablets, it's usually kind of difficult to cut tablets very precisely. So you can usually pretty accurately cut a tablet in half. But you're not going to very easily cut up a tablet and get, like, let's say, 3/10 of a tablet. So you usually, when you're working with tablets, you're going to have to round things off to the nearest half of a tablet or something like that. Kind of depends on the tablet. Maybe some tablets are made so you can divide them up more easily, but just as a general rule, just be aware that, again, consult the documentation. Don't take my word for this. I am not a vet. I am just a mathematician. And, you know, see the documentation for what do you do if the number of tablets comes out to a fraction. So this is the general idea when we're dealing with doses and concentrations of doses. Very similar idea to what we did in the previous video, but now we have to deal with the concentrations as well. To summarize how to deal with the concentrations. A concentration of a dose is the medicine per the solution in which you put the medicine. Now, I'm going to put solution in quotation marks here because it doesn't necessarily have to be like a liquid solution. It could be a tablet or something like that, like in the previous example. So usually what you end up wanting to do is we usually take the reciprocal, which is going to give us the solution per the amount of medicine. And then once you found the amount of medicine that you need for the animal, you can take the needed medicine times the solution per medicine, and this is going to give you the amount of solution you need to actually give the animal. To get the amount of medicine that you actually need, well, to do that, you just have to do what we said on the previous video about calculating how much medicine you need. So all of this stuff can be done by using the following the units, tracking the units, the dimensional analysis, if you want to be fancy about it. So what I would like for you guys to do is to take a look at chapter 10 of your textbooks. This is on dosage and concentration applications. And make sure to go through all of these examples. Now, they actually also show you some little tricks that you can use to follow along with this. So, for example, they use tricks where they keep track of things using these little box tables. And you can do that if you want to find them helpful. I personally don't necessarily find them super helpful. But if you find them helpful, then please go ahead and use them. And I want you guys to do all of the practice sets that are in Chapter 10 because, I mean, there's several of them, but they're not super long. And I think that you guys should be able to work your way through them. Now, one last thing that I want to mention here is sometimes instead of giving a medicine per solution type thing in the way that we've seen with these previous examples, sometimes the concentration is given as a percentage. So let's say a certain solution is 20% medicine, and we give 2 cc's of medicine per 3 kilograms of body weight. How much solution should we give a 5 kilogram dog? Okay, so the first thing we've got to do is we've got to figure out, well, how much medicine should we give in general? So we're going to take that 5 kilograms and we multiply this by 2 cc's of medicine per 3 kilograms. And then the solution is 20% medicine. So that means that there are 20 cc's medicine per 100 cc's of solution. And if I take the reciprocal there, that's going to give me, okay, I really have no room on this board. My apologies about that. Let's rewrite this over here. We have 20 cc's medicine per 100 cc's of solution. That really simplifies to be 1 cc of medicine per 5 cc's of solution. And that means that I need to have 5 cc's of solution per 1 cc of medicine. So I take the reciprocal of this concentration, and now I can multiply by 5 cc's of solution per 1 cc of medicine here. The cc's, okay, so the kilograms already canceled. I just hadn't crossed those out. Cc's of medicine cancels with cc's of medicine, and I'm left with cc's of solution. So this is going to come out to be 5 times 2 times 5 cc's of solution, which is equal to 50 cc's of solution. So the answer is I need to give 50 cc's. Seems like quite a lot for a dog, but, well, these numbers are kind of made up. So some of these problems, and you're going to see these as you go through the practice problems, some of them are going to require you to think back to what did we say about percentages? What did we say about ratios in general? What are some of the things we've done previously in this course? You may have to bring some of those things to bear on these kinds of problems. In this case, we had to deal with the percentages, use the percentages to get a ratio here, and then we take the reciprocal of the ratio. Notice also that this is why it's so important to differentiate between cc's of medicine versus cc's of solution, because I need to cancel out the cc's of medicine to get the cc's of solution. If I just wrote everything as cc, then I might have stopped here and said, oh, hey, look, I'm in cc's. That's the right units. No, it's not the right units. These are cc's of medicine, not cc's of the solution where the medicine is contained. You might wonder, well, why don't we just give the medicine directly? Why don't we just say, okay, screw solutions, let's just use let's just give a pure medicine into there. Well, there might be various reasons for this. Maybe the medicine itself could be very viscous, so it's very difficult to inject. Maybe you have to inject it, and it's hard to do that. But maybe if you mix it in a 20% concentration, now it becomes a nice non-viscous flowing liquid that's very easy to inject. Or maybe it's because the medicine by itself doesn't taste very good, so we mix up a solution that can be given orally that the dog will actually take without trouble because it likes the taste. And that's why we need to mix in some other stuff with it. So there are various reasons why we can't just give pure concentrations of medicine. Fortunately, this method allows us to figure out how much of the actual solution do we give to the animal if we need to give this amount of medicine to the animal. So like I said, practice the stuff that's in Chapter 10. Please do let me know if you run into any difficulties or questions with that. And I will be putting up a quiz for you guys to do over the upcoming week soon.